Now we are going to take a close look at what really makes a quadrilateral cyclic. We may be misled into imagining that a quadrilateral can only be cyclic if it is shown to be in contact with the circumference of a circle, meaning all of its vertices are in contact with the circumference of a circle, but not necessarily so. We have a quadrilateral with two right angles opposite to each other, and we are going to show those two right angles. So there we have the two right angles that are opposite to each other in that particular quadrilateral. Now they are supplementary because they have a sum of 180 degrees. Angles that have a sum of 180 degrees are supplementary, like those two right angles. The sum of those two right angles is 180 degrees. The sum of the other two angles must therefore be 180 degrees also, which will also make them supplementary. Now we are showing that we have 360 degrees and we are subtracting 180 degrees from 360 because the other two angles, the two right angles, have a sum of 180 degrees. We subtract that 180 degrees from 360 degrees and we have 180 degrees left, which means that the other two angles must have a sum of 180 degrees, which will make them supplementary. So because of that, we are sure that we have two pairs of opposite supplementary angles. These two have a sum of 180 degrees. Subtract that from 360, the other two will have a sum of 180 degrees also. Opposite angles as we have them are supplementary in that particular quadrilateral. There are two pairs of opposite angles with sums of 180 degrees, which makes the quadrilateral cyclic. Why is it cyclic? It is cyclic because it has pairs, two pairs of opposite supplementary angles. Two pairs of opposite angles, their sums are 180 degrees. Cyclic does not mean that there is a circle in the diagram, but that a circle may be drawn whose circumference will pass through all of the vertices. There we have a circle. It is possible to draw a circle whose circumference passes through all of the vertices of the quadrilateral. If that is possible, then the quadrilateral is cyclic, even though the circle is not there or is not shown in the diagram. It is cyclic. It is possible. As long as that is possible, then the quadrilateral is cyclic. And as long as it has two pairs of opposite supplementary angles, then it is a cyclic quadrilateral. 1. With or without the presence of a circle, any quadrilateral with two pairs of opposite supplementary angles is cyclic. Any quadrilateral with two pairs of opposite supplementary angles is cyclic, irrespective of what those angles are, as long as the opposite angles have a sum of 180 degrees, then they are supplementary, and we are sure that the quadrilateral is cyclic. Any quadrilateral with a pair of opposite right angles is also cyclic, like the one that we have right in this diagram. Any quadrilateral with a pair of opposite right angles is also cyclic. Why does it only require a single pair of opposite right angles? Because if the two angles are right angles, they will have a sum of 180 degrees, which means that the other two will automatically have a sum of 180 degrees. Therefore, we are sure that we will have two pairs of opposite supplementary angles, and the quadrilateral will therefore automatically be cyclic. Download Richard James Mathematics Resources app from the Google Play Store and have all of your examination solutions, instructional manuals, and other electronic books and booklets in one place. Also, have all of our products and services at your fingertips and on the go. Call or WhatsApp 876-351-9689 or 876-318-8848 for all hard copy books and booklets to complement your studies. Significant discounts will be given to everyone who is registered with any of our programs.